Hey guys, today we're going to learn the chain rule, and this is my favorite rule in all of differential calculus, and that's because it's so widely used, it's so applicable. Okay, so let's get right into it. The chain rule is a rule that was going to be used on the composition of two functions. Now, first of all, this video lecture assumes that you already realize what the composition of two functions is. If this underlined word is giving you problems right now, I'd encourage you to pause this video and go back and review compositions a little bit before you attempt this video. Okay, so assuming that you remember what compositions are, let's move right along. And let's say that we have a composition which we'll call h of x, and really h is not just a function of x, but it was formed by composing two functions f and g, which is to say that I had an inside function g of x, and then I had an outside function f of x, and how I formed h of x was that I took f and I used g of x as its input. Okay, so I have f of g of x, and then I want to take the derivative h prime of h with respect to x. How do I do that? How I'm going to take the derivative of h is I'm going to take the derivative of the outside function. So that's why you see here f prime of g. I'm going to take the derivative of that outside function and evaluate it at g of x. And then I'm going to multiply that by the derivative of g evaluated at x, okay? So it's read as f prime of g of x multiplied by g prime of x, and here I've written it in the ddx format as well. You're going to get a lot more comfortable with this after you've used it on many concrete examples, so let's begin right now. Alright, I've got two functions right here that I've defined. Let's say f of x is the square root of x, and g of x is 3x squared plus 4. Now, how am I going to compose those functions, and then how am I going to take the derivative of that composition? Alright, so the first thing I want to do is form h of x, which is f of g of x, and that means that I'm going to take the statement of g of x and stick it inside the input of f of x. Alright, now to make sure that you have reviewed that properly, why don't you go ahead and take a minute on your own to write down what is h of x when I choose to compose f with g. Okay, so what you should have written there is that you take the outside function f, here it is, it's the square root of x, so I'm going to write square root. And then everywhere I see the letter x inside the outside function, I'm going to replace that input with the entire statement of g of x, okay? So it may help for you to use parentheses there. Anytime you see the letter x in the outside function, you're going to throw in the entire statement of the inside function right there. See, these parentheses aren't really necessary in this case, but sometimes the parentheses are necessary, so I'd encourage you to use them while you're getting warmed up on this. Okay, so you should have got that the definition of h of x as f composed with g is equal to square root of the quantity 3x squared plus 4. Now, that's not anything that we can take the derivative of using our previously learned rules, such as the power rule, product rule, quotient rule. It's not really a product or a quotient so much as it is a composition of two functions, okay? So we're going to have to do the instructions right here. Now, I'd like to just follow along this instructions line, but in order to do that, I should really have written down what is f prime of x and what is g prime of x. And that'll help me to apply the instructions that I've been given, okay? So, to continue for your review, why don't you write down what's the derivative of f of x here and the derivative of g of x there. Okay, so when you're taking the derivative of f of x here, hopefully you realize you really need to write this as a fractional power, because you're going to have to use the power rule on that. So for the derivative there, the 1/2 comes down, and then you get x to the 1/2 minus another 1, so you get x to the minus 1/2. And that's the statement of f prime of x. If you like, you can also see f prime of x this way as 1 over 2 square root of x if you rewrite this negative infractional exponent as what it is in terms of radicals and a ratio. Okay? That's the derivative of f. And what did you get for the derivative of g here? That one was a little easier, huh? That's a polynomial, so then we just get the 6x out of there. Okay, so now we have instructions that says the derivative of h prime of x, is going to be firstly take the f prime, which is this function right here, and compose it with the original function g of x, okay? So I'm going to use this format here because it's a little bit easier. And now here's where the parentheses are going to be really important. You see how I'm copying down the statement of f prime because that's what's written right here? Okay? But it's not f prime of x, it's f prime of g of x. So as I copy through f prime, as soon as I see the letter x, I have to open a parentheses, and I'm going to replace that letter x with the entire statement of g right there. So see, I'm copying the g of x right into the position where the x was in the f prime. Alright, and that takes care of the term f prime of g of x. Alright, that's this term right here, f prime of g of x. Then I'm going to multiply that, it says, by g prime of x. So I'm going to multiply that by 6x. And oftentimes when you're doing this chain rule, there's going to be a little simplification that you might as well enact before, let's say, you would try to evaluate it at any numbers. In particular, 1/2 times 6 is just 3, and oftentimes people like to bring the x out in front, so we can rewrite it like this. 3x times the quantity 3x squared plus 4 to the negative 1/2 power. Or if you want to take that and rewrite it as a fraction, that would be 3x divided by the square root of 3x squared plus 4. And that's the derivative of h with respect to x. Okay, so hopefully you got that. And let's try it the other way too, because just so you know, even though it says h of x is defined with f composed with g, we could also use it on g composed with f. We're just going to end up switching the letters everywhere, okay? So now I want to try it again, but instead of doing it on f composed with g, I'm going to define a function h of x, which is g composed with f. All right? So let's say I say h of x is equal to g composed with f, or g of f of x. What would that function actually be? Okay, so more practice on just forming compositions and getting more familiar with them. Write down, for these same two functions, what is g composed with f now? Alright, I really hope you're trying each one of these on your own, because you've got to be able to do it so that you can do it on your own, right? So if g is the outer function, we're going to do the same type of thing where we copy down g, but as soon as we hit the letter x, we're going to stop and we're going to say, okay, I'm not putting x into the function, I'm putting f of x into the function. So everywhere I see an x on the outer function, I'm going to open up a parentheses, and inside that parentheses, instead of putting the letter x, I'm going to put the entire statement of f of x, which for this is the square root of x. Okay, so that's g composed with f, but really you can see that that could simplify a little bit. So notice I haven't taken the derivative yet. I'm just examining the composition for starters. H of x is equal to 3 square root of x squared plus 4. What does that simplify to? What is the square root squared? Those two things cancel out, right? You can see if I wrote it as x to the 1/2 and squared it, 1/2 times 2 is 1. And so really we get 3x plus 4. Now that's a pretty easy function. That's a linear function. So actually, just from here, could you pause, take a minute, think about what you've already learned, and tell me what the derivative of h of x should turn out to be anyway? Yeah, on a linear function, it's just the slope, which is to say the term 3x turns into the number 3, and then the number 4 turns into a 0. It goes away because the derivative of a constant is just 0. Okay, so whatever we get out of this set of instructions right here for the chain rule should line up with what we've seen here, which is that h of x boils down to 3x plus 4, so its derivative is 3. Okay, so now let's check that by trying to say, what's the derivative of h? Alright, now, when you're looking at your notes, you're going to see a statement of the chain rule here where it's already assumed that h is a certain type of composition. For example, I've stated this as h is f composed with g. But over here, I actually have g composed with f. What am I going to do? Well, in order to make everything straight for myself, here's what I'd like to do. Over on this board where I have this instructions, why don't I just switch the letters G and F, okay? Because that's really how I've stated it over here. So it doesn't matter, because I didn't say what G and F are. They're just letters. So if I want to switch it, so G is the outside function, and F is the inside function, I totally can. That just means I have to switch all the F's here to G's, and I have to switch all the G's here to F's, just like that. okay? Or over here, it would be a g on the outside, f on the inside, and then it would be the f right there, okay? Just a little trick, I just switched the g's and the f's, and that's to match with what I've stated over here. Now when you get used to the chain rule, you won't even be so much caring what you're calling g or f, because you'll be so familiar with what's the inside function, what's the outside function, that hopefully you'll be able to do it after much practice without defining g and f, okay? But if you get yourself in this situation, keep in mind that you can just swap the letters there if you have the letters swapped here. Okay, now let's get back to that set of instructions here. We would like now to do g prime of f and multiply that by f prime of x. Okay, looks like I erased my little derivatives here, so I'm going to put the derivatives back. F prime of x was 1/2 x to the minus 1/2, and g prime of x was 6x. Alright, now practice what this tells you to do right now. We already know that the answer is supposed to be 3. But according to that, what is h prime of x? It says it's g prime evaluated at f times f prime of x. Alright, so let's try to do that. So g prime of x is 6x, composing two functions. Hopefully you're getting more recalling this right now. I'm going to take this g prime, and everywhere I see an x, I'm going to put all of f of x right inside there, okay? So f of x, now don't get this confused with f prime, because one common mistake I see is that people read this as g prime of f prime, and so when they're doing the derivative of the outer one, they throw in by accident the derivative of the inner one. So here's where I want to warn you. As I'm copying along with this, I'm supposed to take the function g prime and evaluate it at f of x, not at f prime of x, okay? So I'm still using the original f of x as the input, just like I did right here. And I'm going to use the f prime of x, but I'm going to use it on the outside. I'm going to multiply by the term f prime of x at the end, okay? So be careful of that common mistake. And as we said, g prime, but instead of the letter x, we're going to throw in f of x. So we're going to put the statement of f of x into the derivative of g prime of f of x here. And then we're going to multiply that by f prime of x, which we've copied down right here as 1/2 x to the negative 1/2. Now, I thought the answer was supposed to be 3. Does anybody see a 3 here? Well, if you're really quick with algebra, then you do see a 3, because what's going to happen here is we're going to simplify using our pre-calculus skills to say that 6 times 1/2, that's 6 over 2. And then we have x to the positive 1/2 times x to the negative 1/2. And do you remember the rules for when you're multiplying two bases that are the same base, and they're to two different exponents? X to the a times x to the b is x to the a plus b, right? So this is actually equal to 6 over 2, which is 3, x to the 1/2 minus 1/2. You see, when you have the same base multiplied by each other to different exponents, you just add the exponents together, okay? So I'm taking the 1/2, adding the minus 1/2, and that adds up to 0. X to the 0 is 1. So this is 3x to the 0, and since x to the 0 is 1, that's 3, and that's what we thought it was from before. All right? Now, on a problem like this, if I had the composition turned out to be this, I would go the easy way. You don't have to go this route for this particular example, but most examples you're going to need to enact that chain rule. Okay? So hopefully you understand all this, and next I'm going to put up a comparison of like a couple different types of functions, and we'll talk about which types of rules we need for each type of function. So by now you should know pretty much all the derivative rules, because this is the last one that we learned. So by now you should know the power rule, of course the sum, difference, and constant multiple rules, and you also know the product rule, the quotient rule, and now finally the chain rule. Okay, so let's ask ourselves the question, which rule or rules do we need for these functions? Alright, and let's say we have 1 over x to the 7th. Which rule do we need for that? Let's say we have this ratio right here. And let's say we have this one right here. Alright, which rules do we need for each one of these functions, a, b, c? And I really want you to make sure that you're keeping up with the class. Pause the video right now, try to answer the question. In fact, now that you know this rule, not only state which rule you need, but take the derivative of each one of these functions. Okay, I hope you're taking advantage of this practice time. Now this first one, did anybody say quotient rule? I hope not. I mean, fair enough, it looks like a quotient because it is the ratio of two things. However, this is an easy one, where this is actually equal to just x to the minus 7. So, although you could use the quotient rule, I would recommend that you do not. Rewrite it as a negative power, and for this one, you only need the power rule. Okay? So the derivative of this, the d dx of this right here, is going to be minus 7x to the minus 8. Alright, so that's the easy way to go. You could use the quotient rule and simplify, and you should get the same thing. Feel free to check that. But if you do, then you will realize that this is the much easier way. So that's the way you want to go on a power like that. Alright, what rule did you need for b here? Couldn't get out of it, could you? Had to use the quotient rule. This is a quotient, can't really split it up or anything, can't really write it as a negative power, so we need to use the quotient rule here. Alright, and if we call the top one f, and we call the bottom one g, then the quotient rule, if you remember it, is f prime g minus g prime f, that whole thing divided by g squared. Alright, so then if we had to take the derivative of this one in b, the d dx of that would be f prime, the derivative of x plus 2 is 1, times g, minus g prime, which also happens to be 1, times f, divided by the quantity x minus 1 squared. Alright, and that actually does simplify. Specifically, the numerator here has a positive 1x and a negative 1x, so those will cancel out, so you really should get just a minus 3 on the top after you simplify. Okay? Point is, you need the quotient rule for that b. And then when you got to c, can you just use the quotient rule for that one? No, you can't. The thing is that on this one here, we had the quotient of two polynomials. We actually had a rational function. Over here, this is not the quotient of two polynomials, it's the quotient of the number 1, but in the denominator, we have the composition of two functions. Can you tell what the inner function is and what the outer function is? We need the chain rule here. We need the chain rule. And if we do need the chain rule, then it's in our best interest to say that h of x is equal to this. And then we want to say, I don't know, since I already have the rule up like that, let's call it g of f of x. What is g of x and what is f of x, so that when we compose g on the outside, f on the inside, we're going to get 1 over the square root of 2 minus x. You'll need to be able to define the g of x and the f of x so that you can follow along with these instructions. Alright, so if you haven't done so yet, go ahead and define for me what the g of x would be and what the f of x would be, so that I get the composition that I have there in part C, and then we'll take the derivative of that. Alright, and there's the rule right there. Did you guys get an answer? I hope you're trying out there. Let's see, the outside function seems to result in getting 1 over the square root of something, and the inside function seems like I could say what's inside the radical. Here's a hint if you're having trouble with this right now, is that if you see a radical, square root sign, a cube root sign, etc., it's usually in your best interest to choose your inside function as the thing that's inside the radical. Okay? So I'm going to choose the inside function as 2 minus x. And what did I do to that 2 minus x? I took its square root and I put it on the bottom. So really what I did was I did 1 over the square root of that. Alright, so if I want to call my two functions the outside function 1 over the square root of x, or I can call x to the minus 1/2, and I call my inside function f of x equal to 2 minus x, then my composition, which I assume here is g of f of x, is going to be, now after I make my guess, I definitely want to check it before I do all this extra work, okay? So let's see, what if I take the outside function, alright, and just copy down what the outside function is. Now as soon as I hit the letter x on the outside function, I'm going to throw in the entire inside function. So now I'm going to throw in the 2 minus x, and sure enough, I got what was stated right there, so I properly defined the outer and the inner function so that my composition would work. You really need to do that before you begin. And then, after you get this, so this checks out and that's great, what we're going to want to do is also have a statement for the derivative of both functions separately. Alright? And when you have that statement, if you have some radicals or something funky like that, you'll probably want to rewrite it in terms of fractional and or negative powers first so that you can enact the power rule there. Okay? So here's g of x, here's f of x. Now everybody write down what's g prime of x, what's f prime of x, and then when we go to get the h prime, we're just going to copy down the instructions just as they're laid out. Alright, one of these is a little bit harder than the other, and I think that's g of x, the outer function, because it's negative and it's a fractional power, but it's still the same old power rule. Copy down the exponent, and then do x to the exponent minus 1. And remember, if it's minus a half, the number is actually going to get bigger, what we call the magnitude of the number, because it's already negative. And think about the number line. We're going left even more on the number line. So that means it's going to get to negative 3 over 2. Minus 1/2 minus another 1 is negative 3 over 2. And what's the derivative of f of x here? This is another linear function. And in that case, the rate of change on a linear function is just its slope. And the slope of this line is minus 1. Using the power rule, you can confirm that f prime is minus 1. Okay, so now let's go ahead and get the h prime of x and the way that it describes, which is that it says, take your outer function's derivative, so take the g prime, and wherever you see an x, you're going to throw in f of x. Alright, sounds fair enough. I'm just going to copy down g prime of x exactly how I see it, except for the letter x. Everywhere that I see the letter x in the outer function, I will leave a big parentheses. And then I will fill in that parentheses the inner function, f of x. Alright, that's g prime of x right there. And then I'm going to multiply that by f prime, which for this is just minus 1. So I'm just going to multiply that by minus 1. Oh look, there's already a minus here. So those two cancel out. So really, I have 1 over 2 square root of the quantity 2 minus x cubed. Okay, so really I just have positive 1/2, 2 minus x to the negative 3/2, but I also wrote it like this. This is the same thing as 1/2, 2 minus x to the negative 3/2, so that you're comfortable with both ways of stating it, okay? So either one of these statements is the derivative of that. Are you guys getting this? I hope you're liking this. As maybe not as much as I do, but hopefully you're liking it anyhow. Let me just throw a few more at you and see once again which rules do we need, and then we'll take the derivative of each. Alright, now sometimes you're not going to have the letter x, maybe you're going to have another letter. When we work with supply and demand functions, sometimes we have the letters p and q. So let's say that we have q as a function of p here. And we have this p over p plus 1 to the 4th, or let's say 2p plus 1 to the 4th, and then let's say we have 50 times the square root of p cubed, or let's say we have p cubed plus 1 to the 18th power. Which rules do we need for each one of these functions up there? And take the derivative of it to challenge yourself as well, just to see where you might get stuck before you watch me do them out. Why don't you go ahead and try to pick out which rules and try to do the problems. See where you are. Okay, so let's talk about this first one here. Ooh, that's a doozy of a problem right there, really. What rules did you say? Quotient rule, that's right, we're going to need the quotient rule because it's a quotient and we can't rewrite it as anything else, so we have to use the quotient rule. Technically, some people out there might be saying, actually, you could rewrite this as a product of p with this quantity to the negative 4, and you would be right. If you'd like to rewrite it as a product in terms of negative exponents and work the product rule instead of the quotient rule, that's fine. But I find in this class, people actually prefer to see it as a quotient as it is and go for it that way. Okay? So I will say quotient rule. And then also, we're going to need the chain rule. And sure enough, we'll need our good old friend, the power rule, which we need every time we have a power. But do you see the reason that we need the chain rule here? The reason is because it's not just p to the fourth down here. It's a quantity, another composition of functions where I've composed the inner function 2p plus 1 to the fourth power. Okay, so this is the part, that's a composition of functions, and we're going to have to apply the chain rule right to this denominator. Alright, that one's going to take a lot of work. How about b? Which rules do we need for b? Quotient rule? Not a quotient. Product rule? It is a product, but it's a product of 50 times the square root of p to the third, so it's actually really just a constant multiple of p to the what? To the 3/2. Right? So actually we don't even need the product rule. All we need is just the power rule. And this is going to be our easiest one. So the d dp, remember, if the input variable is p, then it's the derivative with respect to p. And then 3/2 comes down, so it looks like we've got 25 times 3, which is 75. And then p to the 3/2 minus another half, which is 1/2. Okay? So that's the derivative. That's probably the easiest one. Just do it right there. What about in C? What rules did we need? Not a quotient. It actually is a product. It's a product of the quantity p cubed plus 1 18 times with itself. Okay? So if you want to use the product rule, you could, but you'd be there all day because it's not the product of 2 functions. It's the product of 18 functions. It's the product of this with itself 18 times. So although it is technically a product, I choose not to use a product rule. Really what I'm going to see this one is a chain rule. Okay, this is a chain rule. And let's go back to the original way, f of g of x, which you may see it stated elsewhere, where the outside function is f and the inside function is g. Remember, it's interchangeable. I can work it one way, I can work it the other way. Just keep track of which one you're calling the outer and which one you're calling the inner function. Okay? So go ahead and define the outer function f and the inner function g here. And let's start with C because that's a little bit easier. In A, you can see we're going to have to use pretty much all our rules we've learned so far. So we will tackle A last. Okay, how would you describe that composition in C? What's the outer function? It's a something to the 18th power, right? So if you're still having trouble recognizing these, a good rule of thumb is that if you have a quantity in parentheses raised to a high power, the outside function is x to that high power, or any power. It doesn't have to be a high power. Just it's the quantity to that power is what you're doing on the outside. But on the inside, you're saying, what was that I was putting to the 18? It was this. Oh, sorry. I just got crossed with the letters here. Let's all change them to p's because I did the p's there. So that would be p to the 18, and then g of p, the inside, is the quantity p cubed plus 1. Alright, so hopefully that's what you defined as your inner and outer functions, and then we'll just do the chain rule again, which is to say that if h of x is defined as outside composed with inside function, then its derivative is the derivative of the outside function evaluated at the inside function multiplied by the derivative of the inside function. Hopefully you're getting a little used to that pattern now. Alright, so here we have the outside function p to the 18, the inside function p to the p cubed plus 1. And you probably want to go ahead and just write down what's the derivative of each so that we can use it along with the instructions. Then we'll write down what's the derivative of h with respect to p. Alright, so power rule right here gives us 18p to the 17. And this one power rule as well on a polynomial, 3p squared. What happened to the 1? It disappeared just like all constants do because the derivative of a constant is 0. Okay, so now it tells us the same thing. Evaluate the derivative of the outside function at the inside function, the original g. Don't use this. That's your common mistake, okay? So, f prime, I'm just going to go ahead and copy down f prime. And I'm not going to write down p though, because I'm saving that space. So wherever I see a p, I open up a parentheses. And what am I supposed to put in that parentheses? The inner function itself. not its derivative. Remember, don't put this in there. That's the common mistake, okay? What you're putting in there is the original g of x, p cubed plus 1. Just copy it right into there, all right? And then times the derivative of g with respect to p in this case. So that's times 3p squared. Okay, so everybody take a good look at that, and when you do the final answer, you'd probably want to multiply 18 by 3, whatever that is, and answer with those two things multiplied together and simplified. But in this form, it's really nice, because as you move on with the chain rule, you're going to want to start trying to do it without having to write down all the inside-outside stuff, okay? So let's try to see this visually. If we have the quantity, let's go over here and erase this stuff. I want you guys to eventually get to the point where if I give you this function, you just give me the derivative right away. And here's how it goes in a more visual format. The derivative of this function is, first of all, on the outside, I see a power. So I'm going to do the power rule. Take the 18 and put it down, and then put just what I had before to the 17. Okay, you see me doing that? And then I have to remember my chain rule, which is that if I had anything besides just the single letter variable, so if I had just the letter p to the 18, I wouldn't be doing this right now. But because I have p cubed plus 1 to the 18, I have to remember that when I get done applying the power rule to the outside function, I must multiply the whole thing by the derivative of the inside function. Okay, so don't forget the chain rule. In fact, if you like, the chain rule is actually always in effect. Okay, so another thing people like to see is that actually, if we had, let's just say p to the 18, the d dx would be, bring the 18 down, p to the 17. And if you want to make sure you don't forget the chain rule, keep in mind that it's always in effect. Even on this, what's the derivative of just the letter p? What's the ddp of the function p? It's just the number 1, right? That's a linear function with a slope of 1. So in fact, I am multiplying it by the derivative of the inside function. In this case, the inside function is just p, and the derivative of just p is 1. So really, I'm doing it even originally, before I even knew I was doing it, okay? And that'll make you realize that it's always in effect, but you know, if it's something like this, you really can't forget that term. You don't have to write the one here, it's assumed, but you have to write the derivative of the inside function right there. Okay, so for my last trick, I'm going to do this one in part A, where we have to do this entire thing here. Alright, and hopefully you've got the chain rule written down on your notes here, because I'm going to have to use the whole board just to take the derivative of this function. H of x is equal to p over 2p plus 1 to the 4. Alright, now I don't want you, like in the past things I was doing here, to try to say what's the inside and outside function on this guy. Okay? Because really the only time we need the chain rule is that we need to use the chain rule on just the denominator. So really the outside rule that we're doing is a quotient rule. Because what this is a quotient. It's the quotient of this and that. Now when we do the quotient rule, you have to take the derivative of the bottom at some point, right? And when we get into the point where we have to take the derivative of the bottom, that's when we're going to use the chain rule, okay? So you can see that we need the chain rule, but we don't necessarily want to have to write this as a composition of two functions, because that's actually a pretty challenging question, all right? So what we want to see this as is we're going to see h of x as really the ratio of two functions, f of p divided by g of p. And then we're going to write down the quotient rule, and when we get to the point where we have to take g prime, that's when we're going to use the chain rule just on g of p. Not on the entire thing, but just on the g of p. Okay, so first I'm going to write down the quotient rule, which is to say if we have f over g, the derivative is going to be f prime g minus g prime f divided by g squared. Okay, we're going to have to use the chain rule right when we get to this one term. Alright, so the d, or I'll just say the h, sorry, this is h, sorry I wrote h of x before, I'll call it h of p because we're working with the letter p here. H prime of p, in unsimplified form now, is going to be f prime. So the derivative of the top with respect to p, as we discussed over there, it's just 1. So that's 1 times g. So we're just going to leave the g alone just like that. Okay? And then minus g prime. Let me write this a little smaller. Minus g prime, that's going to be the hard part, so g prime, we're going to have to do the chain rule on that, times f, which is just p, and then divide the whole thing by 2p plus 1 to the 4th to the squared. What happens when I take this and I do to the 4th to the squared? Is this going to be 2p plus 1 to the 6th or 2p plus 1 to the 8? Which one? 8, right, okay, when you're doing it multiple times, x to the a to the b, that's when you have to multiply the a and b, so 4 times 2 is 8. Okay, I've almost got this problem done. The only thing is, I have a big hole where I just wrote g prime because I wanted to do that later. Alright, let's do that part now. What's the derivative of 2p plus 1 to the 4th, okay? Let me do that on the side right here. Let's pretend that I just had... Let's say I just had g of p is 2p plus 1 quantity to the 4th. Do g prime of p. And if you feel like you're getting really warmed up and used to this, why don't you do it the way that I redid c, where I didn't even write down the inner and the outer function. I just kind of did it. Try to do that visually like I did that one over there. Go ahead. Okay, so when I have a quantity to a power, on the outside, I have a thing to the 4th. So I put the 4 down, and I take that same thing and put it to the 3rd, right? That makes sense. That's the power rule. But don't forget what? Don't forget to multiply it by the derivative of the inside. And what's the derivative of 2p plus 1? That's 2, right? So this is actually 8, 2p plus 1, quantity cubed. There you go. And that's g prime, and that's actually what goes right here. 8, quantity, 2p plus 1 cubed. That all times p. And then if we could simplify this, we would try, but that's the unsimplified form. We'll just leave it like that. Okay, great. So practice, practice, practice makes perfect on this. Definitely use the chain rule. Do a lot of problems here because we're going to be using this rule all the time.